Assalamualaikum. My name is Muhammad Rizazani. In this video, I will present the solution for question 1. So, the first questions asks us to construct a 95% confidence interval for the true population mean of daily household water usage. Since the population standard deviation is known and the sample size is large, we use the Z confidence interval formula. Next, we substitute all the values into the formula. 520 minus 1.96, 60 over 144 on the left side, and 520 plus 1.96, 60 over 144 on the right side. Finally, we already calculate the lower and upper limit. So the lower limit is 510.2 and upper limit is 529.8. So the 95% confidence interval for the true mean daily household water usage is 500 is between 510.2 liters to 529.8 liters. To determine whether this claim is supported, we compare 500 liters with the confidence interval obtained in part 1. Since the liter is outside this interval, it is not a plausible value for the population mean at the 95% confidence level. Therefore, the company's claim is not supported. Now we're moving on to question 1b. So from the data that provided in question, we have two sample groups. To find 90% confidence interval for the difference in means, our first step is to calculate the pool variance. The formula used is NA minus 1 S square A plus NB minus 1 S square B divided by NA plus NB minus 2. By substituting the given values, we arrive at S square pool equal to 3139 over 35. Next, we apply the confidence interval formula using the appropriate t-value. Based on the calculation, the 90% confidence interval for the difference in mean score between the two classes is between negative 11.281 and negative 0.719. Question B2. Determine whether there is significant difference between the average score of the two classes. Since 0 is not in the last in the interval, therefore it is differed significantly.
And next, we are going to look at two practical problems in statistics involving estimation and confidence interval. Let's start with question 2. For part A, our goal is to determine the point estimate for both the population mean and the population standard deviation. First, we need to find the point estimate for the population mean. First, we calculate the sample mean, denoted as X bar, and we add all 10 cells figure together, which gives us a total sum of 1470.3. Dividing this by our sample size of 10, we get a population mean estimate of 147.03. And next, we look at the population standard deviation estimated by the sample standard deviation, X. We first calculate the sum of X power of 2, which equal to 216,190.37. Using the standard deviation formula shown on the slide, we plug in our values. Divide by n minus 1, which is 9, and take the square root. This gives us a standard deviation estimate of 1.1624. We use the chi-square distribution technique. With a 95% confidence level, our alpha is 0.05. Using the chi-square table with 9 degrees of freedom, our critical values are 19.023 and 2.7. When we substitute our sample size, 10, and our calculated standard deviation into the formula, the math gives us a lower limit of 0.6393 and an upper limit of 4.5039. Therefore, we can interpret this by saying we are 95% confident that the true population variance for the weekly sales of the supermarkets falls between 0.6393 and 4.504. And now, let's look at the question 3. To do this, we calculate the sample components for both brands. For brand A, with a sample size of 11, the sum of X is 590 and the sum of X squared is 31,700. Plugging this into our variance formula, we find the sample variance of power of 2 to be 5.4545. For brand B, with a sample size of 8, the sum of x is 377 and the sum of x squared is 17,795. This gives us a sample variance of x squared of 4.125. Because we are dealing with a ratio of variance from two independent normal populations, we use the F distribution with a 90% confidence level. Our alpha is 0.1, meaning we look up the critical values at alpha over 2, which is 0.05. Using our degrees of freedom, which are 10 for brand A and 7 for brand B, our critical F table values are 3.64 and 3.14. After multiplying our variance ratio by these table values, we are arrived at our final 90% confidence interval, which is 0.3633 to 4.152. In statistics, if a variance ratio interval includes the number 1, it means a 1-to-1 ratio is highly possible. Therefore, we have enough statistical evidence to conclude that the variance of both battery groups are equal. So that's all from us. Thank you.